In episode 31, titled Windows Patching and Update Channels, we explore the rhythm and reasoning behind how Microsoft delivers updates and how organizations manage them. The patching process is not a random stream of files. It is a structured system designed to balance security, stability, and innovation. Every fix or feature represents a trade-off between urgency and caution, between the need to seal vulnerabilities and the need to maintain reliability. Understanding this ecosystem transforms patching from a chore into a predictable, auditable cycle of improvement. The aim is to see servicing not as maintenance, but as continuous validation that the platform remains trustworthy in the face of constant change. Servicing models exist because static systems do not survive in dynamic environments. Software evolves to correct defects, close vulnerabilities, and adapt to new hardware or standards. Without a disciplined servicing process, organizations would face chaos every time a patch appeared. The model provides governance, rules for what gets released, how it is tested, and when it reaches devices. It separates emergency corrections from planned enhancements and ensures that updates arrive in a form administrators can anticipate. The real value of a servicing model is predictability. When everyone knows the cadence, defenders can plan coverage instead of reacting blindly to surprise changes. To organize long-term maintenance, Windows provides multiple servicing channels. The long-term servicing channel, abbreviated as LTSC, targets specialized systems such as industrial controls, medical devices, or kiosks that require extended stability with minimal functional change. Mainstream channels, including semi-annual or general availability releases, serve typical business and consumer devices that benefit from steady evolution. Choosing the correct channel defines how often updates will arrive and what kind of testing effort will be required. Mixing them without purpose creates administrative confusion, as devices follow different cadences and compliance rules. The best practice is to assign channels based on business function, not convenience. Modern organizations rarely update everything at once. They use rings or waves to stage exposure deliberately. Early rings, sometimes called pilot or test groups, receive updates first to validate stability. Broader rings follow once telemetry shows no major regressions. This staged rollout mirrors biological vaccination. It introduces controlled exposure to build confidence before wider deployment. Each ring represents a trust tier, from experimental to critical systems. When problems appear early, they stay contained within a small slice of the fleet, protecting the broader environment from systemic disruption. The key to success is maintaining discipline about membership and progression through these waves. Pilot groups play an essential role in this ecosystem by serving as early warning sensors. Selected from diverse hardware types and user roles, these machines generate data that reflects how the update behaves across real-world conditions. Compatibility testing alone cannot replicate this variety. Pilot participants should include representatives from business-critical applications, remote workers, and different geographic regions. Their feedback, both technical and experiential, guides whether to proceed or pause. Treating these groups as partners rather than guinea pigs fosters cooperation. They understand that timely feedback protects the entire organization. A well-run pilot phase transforms patching from guesswork into measured adaptation. Telemetry turns experience into quantifiable insight. Each Windows system reports anonymous data about installation success, reboot performance, crash rates, and driver interactions. Aggregated and anonymized, this information allows administrators and vendors to spot trends before they become incidents. High telemetry confidence indicates healthy patch deployment, while sudden spikes in rollback or crash metrics flag underlying conflicts. Privacy-conscious organizations can tune the level of reporting but should resist the urge to disable it entirely, as doing so blinds them to environmental health. When telemetry and pilot results agree, confidence in the update rises significantly. Delivery mechanisms shape how updates travel from vendor to device. Centralized solutions such as Windows Server Update Services, or WSUS, and Microsoft Configuration Manager give administrators full control over approval, timing, and bandwidth. Cloud-based options like Windows Update for Business extend the same governance into distributed or hybrid environments, relying on policies rather than on-premises infrastructure. Each model offers trade-offs. Local repositories provide control and auditability, while cloud delivery reduces maintenance overhead. Some organizations blend both, caching large updates locally while allowing direct cloud sync for smaller patches. The goal is to align distribution with network realities and operational tolerance for delay. Driver and firmware updates deserve special consideration because they affect hardware stability as well as security. Windows Update can deliver many of these automatically, but enterprises often prefer vendor-curated channels to maintain certification and support boundaries. Firmware updates may close severe vulnerabilities, but also risk incompatibility with existing management tools. Coordination between infrastructure and security teams ensures that these updates follow the same approval process as software patches. Treating firmware as part of the patching lifecycle prevents devices from running outdated code at the lowest levels of trust. Occasionally, Microsoft releases out-of-band updates, those issued outside the regular monthly cadence, to address critical zero-day vulnerabilities or severe regressions. These releases demand heightened attention, as they usually target active exploitation or significant reliability issues. Organizations should have emergency playbooks ready for such events, defining how updates are evaluated, prioritized, and deployed quickly without bypassing necessary validation. Out-of-band patches are rare by design, but ignoring them negates the purpose of having an agile response capability. Speed matters most when risk is immediate and measurable. Balancing user experience with security requires thoughtful scheduling. Update windows should consider time zones, work hours, and device roles to minimize disruption. Maintenance windows on servers often coincide with change management cycles, while desktops benefit from overnight reboots or restart deferrals that respect active sessions. User communication also shapes perception. Clear messages about pending updates reduce resistance and complaints. The best patch schedules feel invisible yet deliver predictable results, demonstrating that reliability and security can coexist when timing is treated as part of policy, not as an afterthought. Rollback capability distinguishes mature servicing from reckless patching. Even the best testing cannot foresee every interaction across millions of configurations. Windows maintains recovery options such as uninstallable cumulative updates, system restore points, and feature update rollback periods. Administrators should test these recovery paths regularly so they remain reliable when needed. Version safeguards, such as blocking upgrades that lack compatible drivers or dependent software, also prevent avoidable outages. Confidence in rollback empowers faster adoption because teams know they can retreat safely if an issue surfaces. Reporting closes the loop by showing compliance and coverage across the device population. Dashboards in Microsoft Intune, Configuration Manager, or custom analytics platforms reveal which systems are current, which lag behind, and where installation failures cluster. These views allow management to track patch latency and verify that high-value assets receive attention first. Regular reporting transforms patching from an invisible background task into a measurable security control. When coverage metrics rise and variance shrinks, auditors see proof that change is managed rather than accidental. Security does not end with the operating system. Third-party applications must also join the patching rhythm. Vulnerabilities in browsers, runtimes, and productivity suites often rival those in Windows itself. Modern endpoint management platforms can aggregate vendor feeds and deploy updates for these products alongside system patches. Standardizing this process avoids blind spots where unpatched applications become entry points even as the operating system remains current. A holistic view of patching treats every executable as part of the same trust boundary. A structured servicing program transforms constant change from a liability into a control. By defining channels, pacing updates through rings, validating with pilots, and measuring results through telemetry, organizations gain mastery over the chaos of modern software evolution. Clear scheduling, rollback readiness, and unified reporting close the loop. The result is not merely up-to-date systems, but a living process that absorbs change safely and predictably. Structured servicing does more than manage risk. It builds trust in the idea that secure operations can keep pace with an ever-changing world. Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.